I'm going to be talking about the daylight lab and finding the sinusoidal function that gives us the amount of daylight hours per day on any given day of the year. So we start with this table that has dates and hours of daylight, as you can see. And although it may not appear periodic because we're just given random dates with their corresponding daylight hours, it actually is because in a year the hours of daylight repeat and recur at the same time every year, which is the definition of periodic. And so as you can see, we have our maximum, which is at June 21st of 15.27 daylight hours, and our minimum on December 21st is 9.07 hours. So knowing the maximum and the minimum, we can find the midline, which is the K value, and that's done by adding the two together and then dividing by 2, and that equals 12.17. So this is the midline of the graph we're going to have, as well as the average hours of daylight throughout the year. So that's how you find the K value of our formula h of t equals a of either sine or cosine graph b times t minus h plus k. So now we're going to find the a value, which is found by doing the maximum minus the midline, and that equals 3.1. And that is the amplitude, which is the maximum amount of variation from the midline to the max as well as the minimum. So next we're going to find the b value, which is 2 pi over the period. And because a year is 365 days, we know that that is the period. So 2 pi over 365 is the period. We're going to find the h value. And this is the most complicated of the 4 values because of the fact that we are given the hours of daylight on December 21st when the start date, where t is counted as the number of days after December 31st. So we have to take this into account and shift the graph 10 days away from our starting point to December 31st. And so the shift ends up being -10. So after we have all these values, we can plug them into our original formula, and we get h of t equals -3.1 cosine 2 pi over 365 times t plus 10 plus 12.17. As you can see, we have a negative cosine graph. A sine graph would have worked, but the h shift would have been different than what we have now. We have a negative cosine graph because cosine always starts at the maximum, and we are starting very close to the minimum. So when it becomes negative, it flips down to over the midline. So it starts near 9.07, which is our minimum instead of the maximum. We have the graph of -3 cosine 2 pi over 365 t plus 10 plus 12.17. And so using that formula and this graph, you could plug in any day of the year and you would find the daylight hours for that day. So for example, if I plug in 81.25, there would be 12.17 daylight hours, and this is on March 22nd. And for another example, if I plugged in 263, maybe 263, which would be September 22nd, we would also have 12.17 hours of daylight. So, thank you.